Very good. Can you see? So the correct option is tellurium. ठीक है. मेटलॉइड्स के बारे में कोई पूछे? So there are metalloids. बोरॉन के बारे में you can't, like बोरॉन को फिर भी आप मेटलॉइड किस में रख लीजिए. Then you have silicon, germanium from the second list. Then you, sorry, there's silicon and germanium from the same group. Then you have arsenic and antimony from the same group, right? Then you have tellurium and polonium from the same group. These are the metalloids. See this.
Can you show once again?
Once again. One more thing, in a group, if you go in a group from top to bottom, the metallic character increases, okay? So try this. No, Marita, not right. See, in P block elements, if you look at P block elements, all the elements of P block will have the electronic configuration S2 and NS2 and P126. ठीक है? P में या तो 1 electron होंगे, 2 electron होंगे, 3 electron होंगे, इस तरह से NS2 and P126. Now, these NS2 electrons, these are very near to nucleus. As you go down, NS2 और NP के बीच में आपके पास D subshell वाले electrons आएंगे and you'll also get F subshell electrons. That is why these NS2, they become what? They become inert and they do not react and they do not take part in bond formation. As we go down the group, what happens? These two electrons of the S orbital, they become inert and that is known as inert pair effect. Inert pair effect is solely for P block elements and inert pair effect increases from top to bottom in a group. Achha, if you are not participating in the bond formation, that means what is going to happen? For example, in group 13, the electronic configuration is NS2 NP1, right? NS2 NP1. Now, if these two electrons are not taking part in the formation of any species, any chemical bond, then only NP1 will be taking part. Agar NP1 take part kara, that means it is +1 state. Okay, that means it is +1 state. And when is the NS2 not taking part in the bond formation? Down the group. Okay, so down the group, what is going to happen? The stability of +1 increases. Down the group, and stability of +3 in this case will increase. Or rather, I would say +3 का decrease करेगा down the group. Okay, +3 का stability decreases down the group due to inert pair effect. अब यहाँ पे क्वेश्चन आ गया ग्रुप 13 के लिए, आ सकता है ग्रुप 14 के लिए भी। ग्रुप 14 के लिए क्या होगा, ये +1 नहीं होकर +2 हो जाएगा। ग्रुप 15 के लिए क्या हो जाएगा, ये +3 हो जाएगा। ओके, सो इनर्ट पेयर इफेक्ट क्या केस में ऑल ऑफ दीज थिंग्स वर्क। So the correct option in this case will be A, aluminium, then gallium, then indium, and then thallium. Please write this down. देखिए
Sir, can you just go to the previous question? 5 minutes. Done, sir.
Okay. No. यहाँ पे देखिएगा, इन जनरल हम आपको बता देते हैं the oxides of metal क्या होते हैं बताइए। बेसिक एसिडिक, ऑक्साइड्स ऑफ नॉन मेटल्स क्या होते हैं, एंड ऑक्साइड्स ऑफ मेटलॉइड्स। Tell me guys, oxides of metal are what, acidic or basic?
Basic.
Oxides of and oxides of non-metal?
Acidic.
ठीक है, now this will be basic, this will be acidic, and oxides of metalloids, these are amphoteric. ठीक है, यहाँ पे बताइए which will be amphoteric, how many amphoteric oxides are present? Yes, Krishna, correct. See, sodium is a metal, arsenic आपके पास क्या हो गया, मेटलाइट हो गया। N2 is non-metal, NO is non-metal, and Cl2 is also non-metal. तो मेटलाइट सिर्फ कौन है यहाँ पे, arsenic. So As2O3 is going to be the only oxide which is amphoteric in nature, Okay. Now there is also some neutral oxides, उसके बारे में लिख लीजिए, neutral oxides. What are neutral oxides? Carbon monoxide will be a neutral oxide. Nitrogen oxide will be, and then you have N2O. ठीक है, these are neutral oxide, इनको लिख लीजिए, डायरेक्ट सवाल आ जाएगा तो फिर आपके लिए आसानी है। These are neutral oxides, CONO, N2O. I hope everyone is done. Can we move on? Yes or no, please tell me.
Yes, sir.
See, in P block elements, there are two different parts. एक तो जो conceptual part है, okay, in which you have to learn about back bonding, inert pair effect जो आपने देखा, hydrolysis, oxy acids, allotropes of different compounds, silicates and silicones, and bleaching agent. Okay, so these are the conceptual part. Then you have compounds of P block elements. ठीक है, in compounds of P block elements you have group 13 में आपको क्या क्या देखना है, borax, then you have boric acid, diborane, and alum. Group 14 में carbon monoxide, dioxides, and the carbides of the group 14 elements. 15 में you have to look at nitrogen, NH3, oxide, HNO3, PS3, PCl3, PCl5, and the oxides. ठीक है, oxides of phosphorus. 16 में आपको oxygen, ozone, H2S, SO2, and H2SO4 देखना है। 17 में आपको X2, Cl2, HCl, CaCl2, and xenon fluorides. But इतना सारा तो आप अभी तो फिलहाल नहीं देख पाइएगा। सो आई हैव रिस्ट्रिक्टेड माई सेल्फ, जहाँ से रिसेंटली बहुत ज्यादा सवाल आने लगे। एंड जस्ट टू टेल यू गाइस, 2019 के बाद से जो भी जेई के पेपर्स हो रहे हैं दे आर मोर इम्पोर्टेंट फॉर यू, ठीक है। 2019 के बाद से जो भी जेई के पेपर्स हो रहे हैं दोज आर मोर इम्पोर्टेंट टू यू रादर देन अब आप 2002 के पेपर करने लगी है ना, 2007 के पेपर करने लगी, उससे अच्छा 2009 2019 के बाद के जो पेपर्स है ना वो एनटीए बना रहा है, उनको आप प्लीज कीजिए, ठीक है ना। इन दैट केस व्हाट आई हैव सीन इज इनिशियली पहले के केस में क्या होता था, ट्रेंड्स पूछे जाते थे, ठीक है। ट्रेंड्स पूछे जाते थे कि बॉइलिंग पॉइंट का ऑर्डर क्या होगा, थर्मल स्टेबिलिटी क्या होगा, ऑल ऑफ दीज थिंग्स वेर आस्क्ड। राइट नाउ व्हाट आई सी मोर इज रिएक्शंस पूछे जाते हैं। They will ask you about reactions. They will ask you about reactions. There are some questions about back bonding जो उन्होंने पूछा है. I will be dealing with back bonding, and then I will be dealing with borax H3BO3 B2H6. Okay, and then I will be also dealing with the reactions of nitrogen. ठीक है, मेनली रिएक्शंस ऑफ नाइट्रोजन. ओके, सो दीज आर द थिंग्स दैट हैव बीन आस्क्ड मेनली. और फिर बाकी तो फिर पढ़ने के लिए बहुत सारी चीजें, उतना पढ़िएगा उससे सवाल बहुत कम आते हैं, ठीक है. सो आइदर यू रीड द कंप्लीट थिंग, तब आपको 3 से 4 सवाल बन जाएंगे, ठीक है. बट उतना टाइम तो है नहीं हमारे पास. टाइम मिला तो फिर हम आगे इन लोगों को कवर करेंगे. तो जो ये ग्रुप 13 है, दिस इज वेरी इंपॉर्टेंट, एंड ग्रुप 15 इंपॉर्टेंट है, ठीक है. ग्रुप 15 में ऑल्सो कौन सा, नाइट्रोजन वाले एलिमेंट्स. Okay, so these two I am going to cover, and बाकी में आप देखेंगे they will not be having many things here. Okay, चलिए. First of all, what is back bonding? Back bonding is a coordinate type of pi bond, and what is the condition for back bonding? One species must have lone pair electron, another species must have a vacant orbital, and the size of atom should be small. ठीक है, तो एक स्पीसी के पास लोन पेयर होना चाहिए और दूसरे के पास क्या होना चाहिए, वेकेंट ऑर्बिटल होना चाहिए. Now the very good example is of BX3 or BF3, BCl3, BH3, all of these things. So you have boron and you have fluorines. Okay, boron and you have fluorine. As you can see, boron has what, only 3 bonds. That means एक यहाँ पे p orbital vacant है. This does not have any electron. And fluorine, as you know, it will be having 3 lone pairs. It will be having 3 lone pair electrons. Now what is going to happen? This is electron rich, and this is electron poor. So what is going to happen? This is going to give the electron towards the empty or the vacant orbital of boron. Okay. Similarly, all the fluorines of boron, which are attached to boron, they will be forming or they will be contributing the electron density on its vacant orbital, and all of these bonds will be having partial double bond. And this is known as, this donation from the back side is known as back bonding. Okay, this is known as back bonding. Now the factors that affect the back bonding is extent of back bonding. किसका अच्छा होगा? Boron is a second period element. Fluorine is also second period element. That is why the overlapping of the orbital between boron and fluorine will be very high. Okay, and that is why BF3 is what, most stable, followed by BCl3, followed by BBr3, and followed by Bi3. And BF3 is most stable. क्या मतलब है? It is having least electron deficient. It is what? It is least electron deficient. And it is very different from the order that you would think, because boron is attached to more electronegative fluorine atom. That is why it should be most electron deficient. But because of back bonding, what happens? Because of back bonding, what happens? BF3 becomes least electron deficient. And if it is least electron deficient, that means it is not a good Lewis acid. What is a Lewis acid? Lewis acids accepts electron pair. So BF3 के पास already क्या है? It is not electron deficient, right? It is not electron deficient. इसके पास electrons है because it is getting electrons on the back bonding of fluorine atom, and that is why BF3 is the worst acid. Then followed by BCl3, followed by BBr3, and followed by Bi3. Okay, so please write this down. And also listen one more thing. This type of back bonding in which fluorine is giving electrons from the p orbital and it is giving to the p orbital of boron, तो इसको बोलते हैं p pi back bonding. This is known as p pi bonding, back bonding. ठीक है. एक और होता है जो देखेंगे अभी हम लोग, p pi d pi back bonding. Okay, so this is known as p pi. एक और देखेंगे, that is known as p pi d pi. Please write this down. I will give you some time. Let me know once you're done. Please let me know once you're done.
Done, sir.
So let's look at another type of back bonding, which is p pi d pi. Okay. The case here is, and इस पे सवाल भी आ सकता है आपको. Please see here. You have nitrogen that is connected with 3 methyl groups. Okay. कार्बन के ही ग्रुप का है सिलिकॉन. After carbon, what do you have? Silicon, right? But carbon is second period and silicon is third period element. जैसे ही third period का element होगा, that means it will be having 3D also. And this 3D will be what? It will be vacant. This 3D is going to be vacant. Now, when you have nitrogen that is connected with CH3, in that case, क्या हो रहा है आपके पास? You have pyramidal structure. But when you look at nitrogen, which is bonded with silicon hydride, then in that case, what is going to happen? See here. Nitrogen hai, and then you have silicon with H3. So in silicon, we will have the d orbitals, which is vacant, and the nitrogen's lone pair electron is going to donate the electrons towards the silicon's d orbitals. So it is going from p orbital to d orbital. That is why it becomes p pi d pi back bonding. And because of this p pi d pi back bonding, this is trigonal planar and it is not pyramidal. Okay, it is not pyramidal. So trimethylamine and trisilylamine, they have different structures because of what? Once again, back bonding. Also, one more thing is there. And as you can see, this lone pair electron is given to the silicon. Lone pair electron is given to the silicon. That means no lone pair electron is not available. If lone pair electron is not available, that means this nitrogen will not act as a good Lewis base. है ना? इसके पास बेसिसिटी क्या हो जाएगी? कम हो जाएगी. इसके पास क्या हो जाएगी? बेसिसिटी कम हो जाएगी. As you can see, NCH3, that means trimethyl amine का बेसिसिटी ज्यादा है, and यहाँ पे लोन पेयर किसमें इन्वॉल्व है? बैक बॉन्डिंग में. That is why it cannot do. Next is same case when you have nitrogen की जगह ऑक्सीजन लगा दीजिए आप. When you have ether के केस में there is no back bonding. When you have saline, then in that case you will have back bonding. Okay, and if there is back bonding, so back bond effect of lone pair, it will decrease, and that is why what will happen? The bond angle is going to increase. यहाँ पे this lone pair electrons are pushing these bond pairs. तब यहाँ क्या हो जाएगा? थीटा क्या हो जाएगा? छोटा हो जाएगा. But if you don't have any lone pair, तब ये आराम से खुल सकते हैं. So bond angle will increase. So please write these things down also. इन द केस ऑफ नाइट्रोजन क्वेश्चन यहाँ से पूछा जा सकता है लेविस बेस स्ट्रेंथ पे, और इन द केस ऑफ ऑक्सीजन दे कैन आस्क यू अबाउट द बॉन्ड एंगल. Please let me know once you're done. Please let me know once you're done.
Done, sir.
Try this question first of all. Back donation करेंगे. Which of the following molecules strongest back donation of electron pair from halide to boron is expected? Okay, I've got one answer. Yes, Krishna, correct. Very good. Yes, Marita, very good, correct. Yes, very good, guys. तो यह करेक्ट. अभी देखा था हमने किसमें सबसे ज्यादा, BF3 में. ओके, व्हाट अबाउट दिस वन? Lewis acid character of boron in trihalides follows the order. Yes. Yes, very good. Krishna, Hamza, yeah. Oh, नहीं 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 नहीं, प्रिया देखिए उल्टा कर दिया आपने. Acidic strength is in, it is what, it is directly proportional to electron deficiency. ठीक है. आपने बोला BF3 तो बहुत ही ज्यादा, उसके पास तो इलेक्ट्रॉन है बहुत सारा ना, बिकॉज ऑफ बैक डोनेशन. बैक डोनेशन सबसे अच्छा यहीं पे है. दैट इज ए बोरॉन इज नॉट इलेक्ट्रॉन डेफिशिएंट हियर. ओके, सो दिस इज द ऑर्डर. ये बिल्कुल ऑर्डर लिखा होगा आपने यहाँ पे, तो ये तो है लोवेस्ट एसिड स्ट्रेंथ. सीधा सीधा सवाल. ओके, यस प्रिया, गॉट इट.
Yes, sir.
Okay, so the correct answer will be A. इस सवाल को पढ़िए जरा. BF6 होल थ्राइस के केस में एक और सवाल आया था. आई डोंट हैव Did not take that question right now इसमें, लेकिन BF6 होल थ्राइस के बारे में एक और सवाल आया था. Okay, I think that is correct. Marita, that is correct, I think. Yes, yes, Marita, that is correct. Please see here. Boron is unable to form BF6 whole thrice. Why it is unable to form BF6 whole thrice? Because what is the electronic config? What is the atomic number of boron? First of all, it is 5, right? Atomic number of boron is 5. So it will be 1s2, 2s2, 2p1. Now the vacant, you have s2 में 2 electron and p में you have only 1 electron. Okay. Now in order to form pairs, excited state में क्या हो जाएगा? It will have this 1 electron will be excited like this. So 1 electron here, 2 electron here, and the third electron is here. So the only number of bonds that you can form is 1, 2, 3, and 4 bonds. 4 bonds से ज़्यादा boron बना ही नहीं सकता. It does not have enough vacant orbitals. Or you can say the valency does not permit boron to make more than 4 bonds. Okay, so this is true. It cannot be formed. Size of boron is very small. This is also true. But boron is unable to form because size of boron is very small. That is false statement. So both A and assertion and reason are true, but reason is not the correct explanation of A. That is the B. Okay, the B right answer. And please write this down. What is the reason why it cannot form? Because of lower valency. Valency does not permit. ठीक है, valency नहीं है या फिर orbitals के केस में बोला जाएगा तो orbitals नहीं भी बोल सकते हैं. Both of the reasons are the same reason. I hope all of you wrote this down. Let's look at the group 13 boron family, and the first compound that we have to learn is borax. Okay. First of all, see the structure of borax. Structure of borax में वो पूछ सकते हैं. How many? What is the formula first of all? B4O7 2 negative. ठीक है? B4O7 2 negative और उसमें Na2 डाल दिया आपने तो क्या मिल गया आपको? We have a stable compound without any charges. Now, how many BB bonds do we have? How many BB bonds do we have? We have 0 BB bonds. Huh? B is directly not connected to B anywhere. So BB bond is equal to 0. They can ask now, how many BOB bonds do we have? एक bond तो यहाँ पे देखिए, ठीक है? 1 bond. Then you have this 2. Then you have this 3. And then you have this 4. और एक क्या है आपके पास? Here you have 5. So how many BOB bonds do we have? We have 5 BOB bonds. ठीक है, तो these are the questions that they can ask कि BOB bonds कितने हैं, BB bonds कितने हैं, these things. Now, this is very important. Hydrolysis of borax, यानी कि borax को अगर आप पानी में डालिएगा, if you add water, then what you are going to get? You are going to get alkaline solution because it forms NaOH. क्या मिल रहा है आपको यहाँ पे? Sodium hydroxide, which is a very strong base. Okay, so पानी में डालने से क्या मिलता है आपको? Base मिलता है. इसको पानी में डालने से, बोरैक्स को पानी में डालने से आपको क्या मिलता है? बेस मिलता है. This is very important. Learn this. Next we have the borax bead test. ठीक है, it is used for transition metal cations and they form colored transition metal metaborate. ठीक है, अगर आपने, if you have the borax, if you heat it and after heating you will remove water, ठीक है, and then if you heat it once again, what are you are going to get? You are going to get transparent borax glassy mass. So this NaBO2, ठीक है, this NaBO2 can be used for the detection of different metal cations. They can be used to detect different metal cations. For example, अगर आप copper use कर रहे हैं, that means if you have NaBO2 plus CuSO4, है ना, प्लस आपके पास B2O3 भी है, ठीक है, then what is going to get? You are going to get a blue color borate. क्या मिलेगा आपको? You will get a blue color borate. ठीक है, सिमिलरली इफ यू आर यूजिंग क्रोमियम यू विल गेट ग्रीन कलर, मैग्नीज में पिंक कलर, आयरन में फिर से ग्रीन कलर, कोबाल्ट में ब्लू, निकल में ब्राउन एंड कॉपर में ब्लू कलर. ओके, बट दिस कॉपर वन इज मोस्ट इंपॉर्टेंट, इसको याद रखिएगा. ठीक है, कॉपर में क्या मिलता है आपको? यू विल गेट अ ब्लू कलर बोरेट. सो प्लीज राइट दिस डाउन. सो ये हाई हीट है, 740 डिग्री सेल्सियस आप देख रहे हैं. इट्स वेरी हाई हीट एंड सिमिलरली इवन यहां से आपको हीट किया गया है, इनिशियली भी क्या किया गया है? हीट किया गया है. आफ्टर हीटिंग बोरैक्स हम क्या डालेंगे? सम मेटल ऑफ ट्रांजिशन एलिमेंट्स. ओके, सम cation of transition metal and then you will get some different colors. Please write this down. Let me know once you're done.
Done, sir.
On the basis of this information, try this question. Just a second, mate, just a second. Okay. So Marita, Krishna, and Adriel has answered. Upon heating borax bead dipped in cupric sulfate in a luminous flame, the color of bead becomes green. Is it true or false? क्या ख्याल है guys? Green होगा?
False.
False. The green color is green color form ही नहीं होगा. Both of the statements are false, ना? A will be the correct answer. वो statement 1 and statement 2 are false. All if you got this, yes or no, please tell me. Marita, आपको समझ में आया?
Yes, sir.
फिर आपने B लिखा था, बताइए. B लिखा था? हाँ, B लिखा था आपने. B क्यों लिखा था?
Yes, sir. I didn't notice the color.
अच्छा, कलर भी नोटिस किया आपने. कलर भी इंपॉर्टेंट है. ओके. When borax is heated with cobalt oxide on a platinum loop, blue color bead is formed largely due to. देखिए, कॉपर में क्या फॉर्म हो रहा है? कॉपर BO2 होल ट्वाइस की वजह से क्या हो रहा है? यू आर फॉर्मिंग ब्लू कलर. तो कोबाल्ट के भी केस में क्या हो जाएगा? टेल मी, क्या फॉर्म होगा? चलिए, 2 आंसर मिले हैं. है ना? इसके केस में भी क्या होगा? इट विल बी बिकॉज ऑफ CuPO2 whole twice. B is the correct answer. Then look at another question. Aqueous solution of which of the following boron compounds will be strongly basic in nature? Aqueous solution, पानी में डालने से कौन सा कंपाउंड क्या हो जाएगा? स्ट्रांगली बेसिक. Yes, Marita, correct. बोरैक्स इज वेरी बेसिक ना, जब हम पानी में डालते हैं तो यस कृष्णा डी। ठीक है, क्या बताया हमने, बोरैक्स को पानी में डालने से क्या हो जाएगा, इट विल बिकम हाईली बेसिक। सो एज यू कैन सी क्वेश्चंस आपके हर किस लाइक ऑल ऑफ दिस थिंग्स हैव बीन आस्क्ड राइट। हाइड्रोलिसिस ऑफ बोरैक्स से भी पूछा गया है और बोरैक्स बीट टेस्ट से भी आपको सवाल पूछा गया है। चलिए मूविंग ऑन, ये बताइए the blue green color of bead was observed in oxidizing flame due to the formation of yes correct Krishna correct, Marita correct, CuBO2 hold twice once again. चलिए moving on, next we have orthoboric acid or boric acid. First of all method of preparation में देख लीजिए, we can prepare it from borax, we can create from borax and colemanite, we can create from colemanite. Now in borax what you have to do, you have to add acid in the presence of water, you will get boric acid. ठीक है, in the next case you have to add sulfur dioxide in the presence of water and you are going to get boric acid. Just a second. Okay. Now the property is, first of all, it is a monobasic Lewis acid. कैसा ये? It is a monobasic. That means it is going to, in water, ये कितना देगा H plus ion? It is going to give you only one H plus ion. How many H plus ion it is going to give you? It is going to give you only one H plus ion. Now when you are going to heat it, it is going to form metaboric acid. Then it is going to form tetraboric acid. And if you are going to heat it once again, it is going to form boron nitrooxide. It is going to form boron trioxide, not nitrooxide, boron trioxide. In reaction with alcohol, it is going to give you triethyl borate, which is green edged flame. इसमें क्या मिलेगा आपको? It is you are going to get green edged flame for this. This is the test for boric acid. So please write this reactions. Reaction से ही सवाल आने के ज्यादा chances है. Let me know once you're done.
Done, sir.
See this here. Boric acid is solid, whereas BF3 is gas at room temperature. So solid and gas किस पे depend करता है? Intermolecular force of attraction, है ना? If the intermolecular force of attraction is greater, then it will be solid. अगर कम होगा तो liquid, and if it is none, then it will be a gas. So intermolecular force of attraction. ठीक है? I'm just supposing कि आपको नहीं पता बोरिक एसिड और BF3 में असली रीजन क्या है, बट यू नो द बेसिक्स कि अगर कोई चीज सॉलिड है तो उसके अंदर इंटरमोलिकुलर फोर्स ऑफ अट्रैक्शन ज्यादा होगा, और अगर कोई चीज सॉलिड नहीं है तो उसके अंदर इंटरमोलिकुलर फोर्स ऑफ अट्रैक्शन कम होगा. So according to that, tell me what will be the correct answer. First of all, see, van der Waals forces of attraction are in and itself not very strong. ठीक है? So this cannot be the right answer. ठीक है? Then you have the next option, that is covalent bond. Covalent bond से क्या पता चलता है? You have boron और fluorine के बीच में किस तरह का bond है वो पता चलता है. Not between the molecules, not between two different molecules. It is the force inside a molecule between two atoms. ठीक है? इसके बारे में covalency के बारे में I cannot say anything, right? Covalency cannot determine whether something is solid, liquid or gas. Similarly, hydrogen bond can be a correct option, इसको हम लोग consider कर सकते हैं. Then next we have strong ionic bond. Ionic bond भी किस दोनों के बीच में होगा? Atoms के बीच में होगा. So again, I cannot consider this one. So the only correct option that I can see is strong hydrogen bond in boric acid. Sorry. Try this one. Two more options. Yes, Adil, correct. Very good. Both of the things are true. Yes. Boric acid is a weak acid, and boric acid is not able to release H plus on its own. It receives OH negative, as we have seen earlier. In the case of water, so if OH negative milta hai, then only it can release H plus ion. Okay, so in that we can say that assertion and reason both are true, and reason is also the correct explanation of the assertion. So A is the right answer. Now, the next thing that we have to learn is diborane. Diborane में एक चीज प्लीज ध्यान से रखिएगा about its structure is that it is a dimer due to the formation of three-centered two-electron bond. What is the meaning of three-center and only two electrons? As you can see, hydrogen is forming here two bonds, जो कि form, it cannot form two bonds, pure two bonds. So what happens actually is you have BH3, and there are two electrons here, and this one electron, it also goes sometimes towards this boron. So here we have three centers, one boron, another hydrogen, and another boron. And how many electrons are taking part in the bond formation? There are only two electrons. So it has three-centered and two electrons bond. किस-किस के बीच में? Boron, hydrogen, and then again boron. Write the method of preparation and the reactions of boron. इसमें से आपके पास this reaction is very important. बोराजीन जिससे फॉर्म होता है. Write this down. Let me know once you're done. Please let me know once you're done.
Done, sir.
Done?
Just a minute.
Okay. Done? Yes, Krishna?
Done, sir.
Let's try this. Bromazine, also known as inorganic benzene, can be prepared by the reaction of 3 equivalents of X with 6 equivalents of Y. है ना, 1:2 का रेशियो लिखना था, हम बोले थे ना, 1:2 का रेशियो होना चाहिए. So 1 किसका होना चाहिए और 2 किसका होना चाहिए? This is X and this is Y. We have got 2 answers. Is Madita and Krishna correct? See here. The ratio that you have to take is 1:2, one of borane, one of diborane, and the another of the Lewis acid NH3. Okay? I have to take for, sorry. Second ratio is for NH3. So you have B2H6 and NH3 should be taken in the 1:2. 3 equivalents of what? Diborane, 6 equivalents of NH3. Write this statement. Write this question. Take 2 minutes. Yes, Krishna, I think that is correct. Okay, please see here, guys. This is the product, right? Yes or no? When you add methylamine, ठीक है, तो please look at this product. अच्छा, ये arrow ना, this is the coordinate bond arrow. ठीक है, this is coordinate bond. क्या मिल रहा है आपको? You have boron with 3 hydrogens coordinately bonded with nitrogen with Me3. यहाँ पे बोरॉन भी क्या है आपके पास? इट इज हैविंग 3 bonds and one more dative bond, that is coordinate bond. तो total bonds कितने होंगे? 4 हो गए. That means sp3 and it is will be what? Tetrahedral. Okay, it is going to be tetrahedral. Okay, not अच्छा trigonal plane लिखा था आप लोगों ने, sorry. This will be tetrahedral. Okay, this is NMe3 BH thrice. So this is what? This is a dative bond, coordinate bond. Nitrogen's lone pair electron is giving electron pair to the vacant orbital of boron. Please write this down. Right, next. First, write the reactions, that is method of preparation of ammonia, then the reactions of ammonia, and then for nitric acid. ये तो रिएक्शन आप लोगों को पता होगा, ये दोनों रिएक्शन याद करने के लिए, ठीक है? These two reactions are more important. N2 plus H2 को हेबर प्रोसेस बोलते हैं. I hope all of you remember this. अच्छा, one more thing, नाइट्रिक एसिड के बारे में बता दे रहे हैं. Decomposition by sunlight into NO2. This is also very important. Okay, HNO3 in the presence of sunlight, that is H nu, it is going to give you NO2. Please let me know once you're done.
So what is RH?
Yeah.
Yeah.
This one. Rhodium. Platinum you will use, or you can use rhodium.
So the product of that reaction is NO, right?
Oh, yeah. True. This is NO, not HO. Thank you for pointing that out.
Done, sir.
Okay, after this, write this. So,
Done, sir.
Okay, let me tell you about one thing here. ये जो HNO3 दिया है ना, and it forms एक acid जो बोला है इन्होंने. For example, if you are adding phosphorus, तो फिर आपको क्या मिलेगा? Phosphoric acid मिलेगा. Okay. If you are adding sulfur यहाँ पे HNO3 plus sulfur, तो फिर आपको क्या मिलेगा? Sulfuric acid मिलेगा. Okay, so एक acid का मतलब एक form of the acid मिलेगा. Moving on. In terms of question, write this. मरीता, try once again. दो सही है आपका. एक में I think no, wait a second. हाँ, it's fine, it's fine. Correct, Marita. Very good. Yes, Krishna, correct. Very good. This reaction A with NH4Cl, it is in the method of preparation of one of the compounds. ठीक है? इसमें होगा ये method of preparation of one of the compounds. हाँ, Hamza correct. So method of preparation किसका? Method of preparation of NH3. ठीक है? ये आपको क्या देगा? This is B. What will be A? You are going to react CaOH whole twice calcium hydroxide. तो आपको क्या मिल गया? Calcium hydroxide मिल गया and NH3 मिल गया. A and B. So this is the correct option. उसके आगे आपको देखना ही नहीं है because those two options are not correct in any one of them. A, B, C में ये दो options नहीं है. So A, calcium hydroxide plus NH4Cl, it is going to give you NH3, A or B मिल गया, and then further passing H2 in the presence of CO2, what you are going to get? NH4HCO3. फिर जिसको आप क्या कीजिएगा? If you react with NaCl, you will get sodium hydrogen carbonate.
Sir, can you show the
Right.
previous diagram? One second. Sir,
This
diagram. Yes, sir. Sir, yeah. Done, sir.
The gas produced treating solution, aqueous solution of ammonium chloride, NH4Cl with sodium nitrite. Yes, Adriel and Krishna, I think that is correct answer. Yes, Marita, correct. The answer will be N2. ये reaction है ना, NH4Cl plus NaNO2, it is going to give you what? N2 gas. This is again from the same chart यहाँ पे. This is going to give you BaN3 whole tones. एक ये लिख लीजिए, this is also important. Structure of oxides of nitrogen and phosphorus. Basically structure वाले सवाल इसमें आ सकते हैं. Sorry. Let me know once you're done.